Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about large language models to automate routine work. This episode is based on a tech blog titled Automated Documentation Auditing, Leveraging LLMs for Compliance Verification, published by CVS Health Tech Team. Throughout this episode, we will explore this topic from both business and technology angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. CVS Health is one of the largest healthcare companies in the United States. It has over $400 billion in annual revenue, and it operates spans across pharmacy retail, pharmacy benefits management, and healthcare insurance. Behind all of this is a large and complex engineering organization running hundreds of internal applications, each of which needs to be documented so that other teams know how to operate, support, and recover them. The specific artifact here is called a runbook. A runbook is essentially an operational playbook for an application. It captures things like who owns the system, where the code lives, how to deploy it, how to monitor it, and what to do when something breaks. In theory, every application has one good runbook. However, in practice, at their scale, the results are different. CVS Health's engineering team manages over 200 of these runbooks, and the problem appears. Some pages were complete and current, others were partially filled out, and some were nearly empty. Some of the runbook's ownership fields reference employees who had left the company, and some reference URLs still pointed to placeholder repositories and has never been updated. So nobody had a clear picture of which pages were healthy and which were not. This is a big problem, and one naive approach to solve this is to run manual audit. To have someone goes page by page, check each field, and note what's missing and email the right owner. With 200 of those runbooks with multiple fields in each, that is a tedious and slow process, and it doesn't scale. And more importantly, this manual audit would be just a one-time snapshot. And the moment the audit is done, pages start to drift again. What the team really needed here is a continuous automated compliance check, something that could catch gaps as they appear and routine the right notification to the right person without human involvement. That is a business problem and the gap the team set out to close. Now that we've understood the business problem to solve, let's shift gear and dive into the technical side to see how the team tackled this challenge. The core insight behind the system is simple, but worth stating clearly. Compliance checking for structured documents is actually a language understanding problem. Each runbook field has a rule. It may not be a rigid format rule, but a semantic rule. Some ID should start with a specific format followed by a specific number of digits. A technical owner field is not compliant if it refers to a deactivated account. A GitHub URL would be invalidated if it still contains placeholder text like repo name. These are the kinds of judgments that require reading comprehension and not just pattern matching. This is exactly what large language models are built for. Knowing the benefits of large language model, the team built up the pipeline with 4 different stages. Let's walk through them. The first stage is very simple, content extraction. The system needs to be connected to Confluence via its REST API, and it iterates through all of these 200 runbooks to pull raw HTML content for each of the runbook. This is straightforward plumbing job: authenticate, paginication, and retrieval. But this is foundation everything else rests on. The second stage is about LLM-based validation. The extracted content for each page now get fed into a Gemini model. The prompt is structured around a set of explicitly defined rules, one for each runbook field. Each rule describes what compliance looks like in plain English. For example, the rule for the GitHub URL field says the URL must contain a specific domain pattern, and the field is non-compliant if the placeholder text repo name is still present. This model reads the runbook content, evaluates each rule, and returns a structured JSON response indicating pass or fail for each field. That structured output is what makes downstream processing reliable. You are not passing free-form text. You are reading a machine-readable compliance report. The third stage is notification. If a runbook fails any compliance check, the system automatically sends an email to the application owner listing exactly which fields are missing or invalid, along with a direct link back to the Confluence page. The email goes to the owner's team distribution list with the operating teams copied in. This closes a loop on accountability, where the right people get notified with enough context to take action, without any human manual efforts to triage the results. The fourth stage is to monitor the performance. There is a dashboard surface aggregated view. The vertical PG leads can filter the view by team, see compliance versus non-compliance applications breakout by field, and click directly through to any page that needs attention. This is the visibility layer, which it turns the per-page audit results into organizational awareness. The overall stack is cloud-native and relatively lean, and it saves much of the human efforts to go through all the manual audits. Now, we've discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we discussed the classic documentation compliance problem faced by the CVS Health engineering team at scale. Rather than running periodic manual audits, they built an automated pipeline that pulls runbook content from Confluence, passes it through an LLM with explicit compliance rules encoded in a prompt, generates structured pass or fail results for each field, and routinely target notifications to the appropriate owners. The result is a continuous compliance visibility with minimum ongoing efforts. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.